We will use the shell expansion drawing for this webinar. So I open it, and what you see here is on the bottom, you see the shell expansion. And here on the top, we see the 3D hull model of our ship. We are going to specifically look at the bow of the ship. And let's see. And to be even more specific, we are going to look at this plate. I chose this plate because it is a really nice double curve. I hope that you can see it. So this is what we are going to look at in this webinar. Our software uses polylines as input to make the expansions. So what you need is to have your butts and seams arrangement as polylines on your hull. And there are multiple ways of doing it. What I did, I made a projection with those lines on the hull. So I simply, as you can see, they are all rectangles. So I simply projected them onto the bow. But there are multiple ways. You can also say, hey, I choose this plate and I extract the edges. Another way is to use an existing seam or butt, and then using MasterShip functionalities, you can offset it by, for example, 1,000 millimeters up and 1,000 millimeters down. That's an option. And the final option is to convert your butts and seams from your shell expansion to the 3D model. As I said, in this case, I used just a simple projection. I'm going to show you how I did it exactly. I select those lines. I go to this view, type project, and I select my surface. And now it's projected. So this is this is no rocket science. This is probably quite straightforward to you. Here I take off my butts and my seams. Yeah, so here, let me also take off this. So now you see this projection, and it's exactly on my seams and butts arrangement. I'm going to delete those lines. So that's how I did it. And now we are in fact ready to make the expansion. But before we do so, we are going to check if the butts and seams that we just made are also compliant with the rest of the ship. So we are going to convert it to our shell expansion. And then we can see if there's maybe a conflict with other construction elements. So therefore, we go to the shape ribbon in MasterShip. We select the functionality from 3D to 2D, and that functionality will will do what it says. So it will convert those 3D lines to our shell expansion. So I select this. I select the butt, the seam, and the other butt. Then I press enter, and at the moment I press enter, you will see it appearing here on the shell expansion. So it's now here. I'll show it in the top view. So these are the butts and seam lines that we just projected. I have to say this looks fine to me, but we can also have the case that, for example, this seam line was too close to this deck. Maybe this is not the case at the moment, but if it was, then we can simply adjust it. So then we say move. We move this up at, I don't know, maybe 150 millimeters. We also adjust the butts accordingly. And oh, no, get it. Also this butt. And then we can project it back to the 3D model. Before I do so, I convert those to polylines because that usually gives a slightly better fit. So I convert them. So we have now 3 polylines. And then I'll go from 2D to 3D in this case. But at this moment, the lines are generated. Take a little bit of time. and it's done. So let me turn off this bow plate here. Yeah, what you see now, so this is the new seam. I'm going to delete the old one. And I'm going to also delete the old butts. We don't need them anymore. Okay, so our butts and seams arrangement is now done. We are happy with it, and now we are actually going to make the expansion. We go to the double curved here because it's a double curved plate. We select our lower seam. We also need a middle seam since our method for making the expansions uses crosses, and those cross all at the middle seam, so to say. We can either select it or construct it. We don't have a middle seam at this moment, so we need to construct it. To select our upper seam and then our frame lines to construct the middle. No. So now we have the middle seam. We select our aft butt. We select our fore butt. Give this expansion a name. We called expansion at frame 44, maybe. Small name. Yeah, we can also do it smaller, whatever you like. Then it asks us to select objects to be marked. Well, usually it are the frame lines. And we give it a factor of accuracy. Usually I set this on the highest level. You can also do it a bit more coarse, and sometimes a little less fits just better than a little more fine. Sometimes you have to play with it, but usually it's fine. Then the next question, do we want excess material? Now, Jacques already told us, no, we don't. So we go on, and then we get these lofting points. So this was this accuracy I was talking about. Now it looks pretty okay. You see how they cross on that middle line. So we accept the lofting points, and then our part is generated. And yeah, what you see here is in fact a MasterShip part, as we call it. And a MasterShip part has a identification. We can assign it a material. We can assign it a thickness, so make this 12 millimeters thick. We can assign it a production unit. In this case, it's already defined. It's S10.3. We can assign it a modification. So maybe we say this needs to be beveled because it's a big thick. And maybe we also want to paint it. Let's see if it's already in there now. Paint. And now we have this information, and all this information will be saved in our project database. And the advantage of saving it in the project database is that it later can be extracted from that database, and we can make, for example, reports, but we can also use it for the nesting and the generation of the cutting code. So if we are happy, then we can press OK. Let's see, it already exists. So we redefine it, that's okay. And now at this moment, two things happened. One is we have our plate. And the second is that we got a file with all the data which is generated while the expansion was made. So that contains stretch data, length of butts and seams, and others. I'll show you in a bit. First, going to look at the plate. So this is our plate. Yeah. Okay. So if we now look at this plate, then we see here in the middle, we see the name of the plate, the expansion at frame 44, the thickness, and the production unit. We also see the indication of what is up and what is forward, and we see our frame lines. So the green lines are the marking lines, of course. And this yeah, is already ready to be cut. But before we do so, we can apply maybe some more markings. So we can indicate the frame lines. We can indicate some modifications to be made, for example, beveling. My computer needs a bit of time to think. Ah, there it goes. So we can go to mark text. Then we select, for example, this line, and we say frame 44. We place it here. let's do a second, frame 45, etc. But we can also do this for the edges. So we can say on this edge, if it needs to be beveled, we can say, for example, this side, bevel at 30 degrees. Depends on the convention that you use, but it looks something like this. So, and now this is also indicated on the plate. So this will be printed before it is cut. You can do that for all these sides, of course. Next step would be to make molds so that we can shape it and produce it in the shop floor. Before we do so, we are going to look at the stretch file in the Excel or the stretch data in the Excel file. Let me see where it is. It's not here. It is probably hidden somewhere. I know it's behind this PowerPoint. It was a preview of our end slide. Okay, so this is the data which is generated when our plate is made. I will skip over it. Usually you do not open this file at all. Only for real complex cases of if you are really interested in this data, then you do. But yeah, usually it's not needed. What you see is here some ordinate positions, and I think this is the most important one. This is the stretch data. I can make it a little bigger for you. So this is the stretch data in absolute values over here between the ordinates. And then we have here the stretch data in between the ordinates, but then as relative values. Now the average stretch in this plate is 0.15 on the lower seam and 0.14% in the upper seam. Meaning we do not see much problem in the stretch, so I don't think it will crack during production or something. Might the stretch be really high? So in a very complex case, maybe somewhere in the bulb where it really needs to be stretched or shaped, then you can decide to maybe cut that plate into 2 plates. So and then finally there's some yeah, here the length of the seams on the ship and in the lofting, and now a lot more. We go back to the model. So that's the stretch data, which you very often not use. Okay, making molds. So we have the plate, it's ready to be cut, but we need some molds to shape it. Making molds is pretty straightforward and goes relatively quick. So therefore we go to the NC ribbon. And then we have the functionality to select the plate mold set. I'm going to turn off this layer. I have a few mold lines prepared here, which we need to use. So it asks me to select the curves, and I had my curves very well prepared on that seam which was initially there. But as you can see, they are now too long. So let me trim them. We select this as a cutting edge. Trim the mold lines like so. So now our mold lines are tailored to our new seam, and then we can actually start making the molds. So we do plate mold set. We select our curves. I press enter. And then we have the molds. So this one looks a bit strange now, but it will be all right. So they are now on the inside of the ship. But in fact, we want to have them on the outside of the ship. So we can reverse the direction. And now, yeah, the molds are in fact already made. We can specify the height. So we can say, oh, we want to have them 300 millimeters high. But that's in fact it. The molds are made. So we can take a look at how this looks. So here's the bow. This plate is also too long. We can trim that, serve trim. This. So now that plate is also trimmed. And then we can orbit around the plate. And these are And this is now, in fact, already our final product already. The only thing left to do is to make the molds ready for milling. So we go to the plate mold set. Let me turn on those layers. We go to two molds. It's a functionality. We select our mold set. We say we want to have them here. We give it a name, expansion F44. Let's make it a bit shorter, maybe expansion 4. We make it out of wood. We give the molds a thickness of 12 millimeters. The section called S10. And now the molds are being generated. So if we look at this on the top, then we see 1, 2, 3, 4, 5 molds, and they are already positioned from left to right. So this mold belongs to this line, and this mold belongs to that line, etc. You can also see it 1, 2, 3. You see again the thickness. And that's all there is. Yeah, one final thing that you could do is mark again text to the marking line. So you can say here is mold 1, for example, and then you place it there. But that's detail. Everything is now ready to be cut or milled. So next step would be for this plate to generate cutting code. We are not going to do that in this demo, and same goes for the plate molds. What I did as a final step is that I made a workshop drawing out of it. It looks like this. It's simple and straightforward. So here I put some dimensions on it. The distance between the molds on a horizontal level, and also the angle at which the molds are placed. And that's in fact also the only information that you need. And that makes this story complete. We started with defining our butts and seams. We transferred them to the shell expansion, adjusted it, made the expansion, made the molds. And now the last step is to actually take it into production. And I'm sure you've already seen the last slide, but this concludes the webinar, and we thank you very much for attending. I haven't seen any questions. Have you, Jacques? No, no. So we do not have any questions at the moment. May you have a question, then feel free to contact us. You can contact us at info@mastership.nl or at our personal email addresses. And once again, thank you very much for watching.